Hi, I'm Sam Richardson, and I'm here with Adam, Aaron, Akash, and Nick. And this is
NBA Tonight. Tonight on the show, we're going to be talking about a question that we've been receiving often about what variables go into affecting the guards' guaranteed salaries in the NBA. Based off of the statistics that we found on Kaggle.com, we're going to be analyzing out of these 12 variables, the statistics on players' performance, which ones are most relevant in determining the guaranteed salary for NBA guards. So the motivation for us to do this was nostalgia number one, because all of us on the team here, we all played basketball in our youth, and with big contracts coming out in all the sports world, but especially in the NBA, some of these contracts, people are questioning whether players are deserving of them or not, and how to estimate what their value actually is to a team. And our context for this is the relevant statistics from the NBA guards that reflect their performance. And like I said, we're trying to find what the correlation is between the guaranteed salaries and the variables that were listed previously, such as age, games played, minutes played, player efficiency, etc.
Some of our assumptions for the data we found are like injuries. Some players get hurt, some like that affects their stats for the year, they miss games. Field goal percentage was not in our data, and that is a huge factor to it, but we accounted for it like in that it's assumption that could affect it. Another one is rebounds. Point guards usually are not the type to rebound, so that usually does not affect their guaranteed salary. And then the data, so we retrieved it from Kaggle.com, and includes 236 rows, 18 columns of variables that can affect guaranteed salary. Like Aaron said before, age, games, minute played, etc. Data's ultimate importance was the guards' like position and how much they get paid based off of like something. An example would be like blocks is not as much because like guards not usually the blocks. They're assisting players, so that's a big factor. Assumption: the relation between X and Y is not linear, so that's why we like the normal distribution of errors with mean 0. Size of data is greater than 30 for central limit theorem to apply. Alright, and then we're going to clean the data, so we sorted it through like highest amount of pay, start with that, then down. We use correlation matrices and multiple linear regressions, and we based off the p-values, and if they're lower than 0.05.
We're going to go into our business question hypothesis here, and basically we have set it up so that the null is going to be 0 and anything else is going to be our alternative, which is greater than or less than 0. So what we're trying to prove is that if our analysis is correct in rejecting the null, that statistics do not affect guaranteed salary, but any indication that they do have an effect, then we are going to reject the null, and this is going to be whether it's a very significant change within that, the indication showing that guaranteed salary is affected by statistics, or if it's a very minute, small sample, we will still take that into consideration and show that there is some impact on guaranteed salary.
So the first step we did was to clean our data. Pretty much we organized it by guaranteed pay as the highest, and then we just went off that for the rest of it. Salaries, the highest salaries first and the least is on the bottom. Step 2 was we made a correlation matrix. This showed us what variables correlated. So as you can see here, games played and minutes played had a very high correlation. PER and true shooting percentage had another high correlation. So we took both of those out because that meant that these variables could be taken out and our data still wouldn't be affected. Step 3 was we took out those correlations. We took out games played and minutes played first because they had the highest correlated values. So as you can see, the first variable we took out was games played, and then going on, we just did this over and over again to show that to try to get a p-value that was beneath 0.5, which showed our significance. We ran a total of 11 regressions to show this. So these are our first residual plots, as you can see. And these are our final residual plots. Minutes played and assist percentage is what we found that were very significant to our data. After running our 11 regressions, this is a regression model that we came up with. So as you can see, if a player plays no minutes and gets no assists as a guard position, they won't be getting paid at all. If they play like a minute or they play 2 minutes, they'll be getting paid around $15,624 plus another $668,273. That's about if they average 1 minute and get around 1 assist a game.
So something really interesting for our data was the time series. So as we stated before, all of our data was only over the 2017-2018 season. So we needed to find a way to show, some form of time series and seasonality within our data. So instead of using, that one season and, the guaranteed salary, we flipped the script a little bit and used age as our x-axis and moved the guaranteed salary over to the y-axis. So doing this, we were able to use 3 key models. So we used naive, all moving average, and exponential, but we were actually unable to use the 3-year moving average because this was, unlikely, seeing as all the ages had a lot of repetition and it wasn't, the same thing with consistency. So we just decided to exclude that from our time series data. So this is our naive forecasting plot. This basically shows, our MSE, which, at first glance it seems very high, but compared to the other, statistics that we'll show, this is actually one of the best ones that we have to offer. You can see how we did it with the age on the far left and the guaranteed, and using the naive, we simply, copied and pasted it over, created our error and our squared error, and got our MSE out of that. Using the same thing with exponential smoothing and data analysis using Microsoft Excel, we were able to do something similar here, creating our forecast plot, which gave us the same results for the error and squared, different numbers obviously, and then this actually concluded an even higher MSE. And finally, our all-moving average. So this is something that we thought would actually be extremely beneficial, seeing as it would average out all the numbers that were listed below and keep a consistent number going forward. As you can see, it starts to get lower and lower in our forecast here, and this creates an error. And we get the squared out of that as well, same process as before, and you get the MSE up here as well. Alright, so once again, touching on our guaranteed salary by age, we created a plot here to show you this, so it's graphically evident. We started out here by showing all of the ages on our X, like I stated previously, and our guaranteed salary on the Y. We found the prime age to be somewhere between about 26 to 29. This explains a lot because, when they come into the league, they're very young, getting rookie contracts, not making as much money initially, and having to prove their worth within the league, which, makes a lot of sense, as you can see, getting into their prime age, as we've established, making up to $200 million with Steph Curry. And then also, they kind of start to make less and less money as they get older. They have less worth to teams and the owners who don't believe that they make as much money, even though, as we've shown, some of the statistics might say otherwise. But in terms of age itself, for the purpose of the time series, we've determined that over time, you're going to have a horizontal trend that will peak at about the 26 to 29 age. And then once again, touching on everything we've just talked about, you have your naive MSE, exponential, and all moving average. These are significantly large numbers with the amount of money that is going into the NBA and that these players make. We determined that the best option here is going to be exponential smoothing because that will provide us with the smallest MSE possible.
Since our R-squared or our variation was only 28%, we determined that our model was not very strong. A few ways we would have changed this model would be to add more variables such as age or field goal percentage, because we believe both of these would affect their pay. After running multiple regressions, we concluded that the independent variables minutes played and assist percentage affect guaranteed salary the most. This is because their p-values were less than 0.05. We decided to use 0.05 as our alpha because this was the alpha we used most in class. And R-squared on our final regression was 28%, which means that 20% of the values fit our model. So all of these variables, we concluded that they do not correlate very well with guaranteed salary because, like I said before, their p-value was actually greater than 0.05, which was our alpha. So in conclusion, like I stated previously, we determined that minutes played and assist percentages had the most correlation to guaranteed salary, and this is because their p-value was less than 0.05, which was our alpha. Furthermore, this was our regression model that we got, and like Akash stated previously, if you play no minutes, you're not going to get any assists, you're not going to get paid, and if you're playing about 1 minute, this is about how much you make due to the equation.